Have you ever wondered how computers talk to each other? It's like they speak a secret language, sending messages back and forth across the world. Well, this language isn't magic, though it is pretty amazing. It's called the TCP/IP model. And it's the backbone of the internet. TCP/IP stands for Transmission Control Protocol, Internet Protocol. It sounds complicated, but it's really just a set of rules. These rules help computers break down information into small packets and send them across networks. Think of it like sending a puzzle through the mail. You wouldn't send the whole thing at once, right? You'd break it into pieces. The TCP/IP model has 4 layers, each with a special job. These layers work together to make sure your emails, videos, and video games get where they need to go. It's like a well-oiled machine, with each part playing a vital role. In the next few sections, we'll explore each layer in more detail. We'll use simple language and fun examples to make it easy to understand, even if you're new to the world of networking. So, buckle up and get ready for a wild ride through the fascinating world of TCP/IP. Let's start with the layer closest to us, the application layer. This is where we interact with the internet, using apps and websites. Think of it as the top floor of a building, where we live and work. When you check your email, browse the web, or watch a video online, you're using protocols in the application layer. Protocols are like different languages that computers use to communicate. For example, HTTP, Hypertext Transfer Protocol, is the language of the web. Other important protocols in this layer include FTP, File Transfer Protocol, for sending files, SMTP, Simple Mail Transfer Protocol for email, and DNS, Domain Name System, for translating website names into IP addresses. It's like having different departments on the top floor, each with a specific job. The application layer doesn't worry about how data gets sent or received. It just provides the tools we need to access and use the internet. It's like using a phone. You don't need to know how it works to make a call. Now let's go down a floor to the transport layer. This layer is responsible for making sure data gets delivered reliably between 2 devices. It's like the mailroom of our building, ensuring our letters and packages reach their destination. The transport layer has 2 main protocols, TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. TCP is like sending a registered letter. It's reliable and guarantees delivery, but it's also slower. UDP, on the other hand, is like sending a postcard. It's faster and more efficient, but there's no guarantee it will arrive. Imagine you're sending a love letter. You'd probably use TCP because you want to make sure it gets to your sweetheart. But if you're just sending a quick update to a friend, UDP might be a better choice. The transport layer doesn't care about the content of the data. It just makes sure it gets where it needs to go in the right order and without errors. It's like a dedicated postal worker, ensuring your mail is delivered on time and in one piece. Section 4, the network layer, finding the right path. Let's head down to the network layer, the ground floor of our building. This layer is responsible for routing data packets across networks. It's like the lobby of our building, directing visitors to the right floor. The network layer uses IP addresses to identify devices on a network. An IP address is like a street address for your computer. It tells other devices where to send data. This layer also uses routers to forward data packets between networks. Routers are like traffic cops, directing data packets to their final destination. They choose the best path for the data to travel, just like a GPS helps you find the fastest route. The network layer doesn't care about the data itself, just like a mail carrier doesn't read your postcards. It just makes sure the data gets to the right network and device. Section 5, the link layer, the nuts and bolts. Finally, we've reached the basement, the link layer. This layer is responsible for the physical transmission of data over a network. It's like the foundation of our building, providing the physical infrastructure for everything else. The link layer uses MAC addresses to identify devices on a local network. A MAC address is like a unique fingerprint for your computer's network card. It ensures that data is sent to the correct device on the network. This layer also deals with the physical transmission medium, like Ethernet cables or Wi-Fi signals. It's like the plumbing and electrical wiring of our building, carrying data between devices. The link layer doesn't care about IP addresses or protocols. It just focuses on sending and receiving data bits over the physical network. It's like the construction workers who built the building. They don't need to know what goes on inside, they just make sure it's structurally sound. And there you have it, a whirlwind tour of the TCP/IP model. We've gone from the penthouse suite of the application layer all the way down to the foundation of the link layer. Just like a well-coordinated team, Each layer plays a vital role in making the internet work seamlessly. So next time you're browsing the web or sending an email, take a moment to appreciate the magic of TCP/IP.